Actually, you think because. Yeah, that's right. You want this open pen. It's just it's one of those pens that have like this little handle. The what? Something broken is here. Yeah.
It's stuck in my head now. So does the
That's like
date. Just Dave's video. He's putting that on
He's usually
I have like the DVD things to actually play on.
All right, give me names for these 4 compounds, ladies and gentlemen. And this one right here requires a Roman numeral.
This isn't the right one.
Because that's one that needs a Roman numeral. So that's the one that needs a Roman numeral. Yeah, yeah. Just trying to draw attention to that for you. Since my O doesn't really look like an O. Positive there. Now that's better.
Thank you.
You're welcome.
Can you fix the N? Because it kind of looks like a backwards C.
Which N?
The N at the end of Roman.
It looks like a backwards C?
Yeah. It does.
Roman?
That says Roman.
Are you okay?
I am not making anything.
Isn't it rain?
Well, these are formulas. So if I asked you to write the formula, you'd be done.
Oh, yeah.
What? Oh, it's been fine as frog hair on a toad's butt. For Cocoa Puffs?
Yeah.
Okay, nothing wrong with that.
It's easy enough. You're sort of locked up. I can't figure out what's the last one? BH3. Because hydrogen is 3. Yeah, that's what
Oh, Lord. Yeah, that's why I think it is.
The last one was a zero.
It's used there.
It is what we hydrogen carrot. But we're going.
This is why.
Oh, perfect. Am I going crazy? Am I going cuckoo?
So basically, 4 would have a -5 charge, right? But then, isn't -2
You put 4 on hydrogen?
No.
Oh,
so we're
really?
good.
It doesn't sound right.
But is it
I think Caden's gonna fit too.
I know, but it actually. Well, this is an awesome.
Oh wait, no, it doesn't. It doesn't. No, it doesn't make sense either. This hydroxide has a negative charge.
And
Could it be that?
but there's no one, so I don't understand like how that.
Is there any element that affects?
No.
Could it be boron?
Oh,
It could be.
no,
It could be.
no.
It loses 3 ounces. Why not?
So but can it be a non-metal and metal?
Because then you're losing the O.
If you lose all that.
Yes.
Oh.
I mean, if you lose all that.
Yeah, I don't
finish it.
Yeah.
And you can't even lose.
I think it's on these somehow.
C senor.
Like,
That's why they're
Or
launching.
if you lose 2, then it'll be 1.
Well,
And then,
Is it 107?
because you can lose 3, and then the 3 would go down.
Just he did. He
And
just he
then
did a correction.
hydrogen.
Or something.
Yeah, it is. So it doesn't make sense.
before you.
Boreal.
That's
So it
not,
would just be
maybe.
borate, but if it loses 3,
Boreal.
We're just gonna write it down.
It's really boreal. Yeah, that's what it is.
NH4Br.
Ammonium
Ammonium.
bromide.
Good job. Anybody else? Anybody else have anything different? CaC2O4.
Oxalate.
Anyone have anything different there? FeClO2 in parentheses 3 with a Roman numeral, please.
Iron free chloride.
What was the last part? I'm sorry.
Chloride.
Last three letters, just so that I'm making sure I hear you correctly.
ITE.
Anybody have anything different there? BH3. BH3. Nobody? No one. Why?
Does it not exist?
Does exist.
Mr. Brown,
Yes.
did you get 3 for your Roman numeral?
How did I get 3 for my Roman numeral? Good question. Okay, chlorate has a charge of what?
-1.
Charge of -1. And how many of them are there? 3. For a total charge of -3. Okay?
But if it's chlorite, and then there'd be less. Oh, it's the oxygen.
Good catch. Chlorite, it does change the amount of oxygen. What it doesn't change is it doesn't change the charge.
Yeah.
So this is -3. This would have to be a +3. I didn't finish that. And since there's only one of them, that one needs to be a +3. Okay? So this is good. Is this one good? You bet. Is that one good? Yeah. This one's good as well. Okay? So now the question is, why can't you name that? What's wrong? What? Thank you. I'm glad you noticed that before you wrote a compound. You can't name that yet. You haven't been introduced on how to do that. That's today's problem. Okay? That compound can exist. And let's be honest, ladies and gentlemen. Could you name a compound that doesn't actually exist? Absolutely. We are giving you a naming system. This naming system says if I combine this and this, and as long as they're on the periodic table, I should somehow be able to name it. I'm not saying every compound I gave you on those worksheets actually exists, especially when you get into sulfites and hyposulfites and persulfates and things like that. Some of those may not actually exist. That's not the point. The point is, do you understand the naming system enough that if I give you something, you should be able to name it? You guys have been doing a wonderful job with that. You really have. Okay? Well, that is another naming system, ladies and gentlemen. Why do atoms combine? To become stable. How do they become stable? What does an atom do that makes it become stable? You're a little bit ahead. What does it actually do that makes it stable? It fills its valence shell. It fills its valence shell. That's what makes it stable. Why are the noble gases already stable? Their valence shell is already filled. They're already that way. They don't need to fill it. Okay, this is why we say atoms become stable. Because the stable atoms don't combine. Okay? And the stable atoms have a full valence shell. Now, how can you fill your valence shell if you are an atom? What's that? Absolutely. By gaining or losing electrons. The problem is the only way you can lose an electron is if there is something near you that will gain it. Actually, there's a third way too. There's a third way. Anybody remember what the third way to fill the valence shell was? Kind of. The third way that you can fill the valence shell is by sharing electrons. Okay? My wife has informed me that she wants to go to the movies this weekend, ladies and gentlemen. That means I got to buy tickets. And when I get there, you have to buy snacks. You can't go to the movie and not have snacks. So when we go to the movie and we get there, we share popcorn. Okay? Now, what are the two ways you can share something, ladies and gentlemen? Okay, you're talking about physically. Yes, I'm talking about the two ways that you can share something with someone. Say you won some money. What are the two ways that you could share it with another person? By splitting it. Well, you always got to split it, right? So let me rephrase this. What are the two ways you could split it?
Evenly or unevenly.
Thank you. Evenly or unevenly. You get half, I get half. No, I get 80% because I bought the winning ticket. You get 20%. Maybe it works, maybe it doesn't. My wife and I, we go to the movies, we split the popcorn 50-50. Okay? Problem is my half is on the bottom and I have to help get to it. Okay? So there are two ways that you could share, evenly or unevenly. That's going to come in handy in Unit 8. Okay? For now, atoms can share electrons. But only certain types of atoms can share electrons. What kind of atoms can still fill their valence shell by sharing? There's only two kinds, right? I mean, you got a 50-50 chance. But please, before you answer, think about what each type of atom needs to do. And tell me which one can fill its valence shell by sharing. Or look at the board at the type of compound we're going to name today.
Metals.
Okay, those are our two choices. Good job, we got them both out there. What are metals trying to do with electrons?
They're trying to do.
Oh.
No, they're trying to.
So when you're sharing, it's like you have something even though it's not yours, right? Is that what metals want to do, though? Do metals want to get more electrons by sharing them with another atom? No.
I just.
No, hey, you took a chance. I appreciate that. You had a 50-50 chance. And maybe you didn't think about it that way. But now let's think about nonmetals. Nonmetals are missing electrons, right? So, okay, you're missing an electron and I'm missing an electron. Well, if we take some of our electrons and split them between us, maybe we can get to 8. Maybe then we're stable. And that is what, in fact, happens with nonmetals. They are the only type of elements that can share electrons. They're the only ones. Why? Metals are like, hell no, I'm not sharing with you. I want to lose these things. If I share it, it's like I got more of them. Now I just got to get rid of even more. But nonmetals are like, well, wait a minute. Maybe if I share, it's kind of like I got that extra one that I need. Right? Nonmetals are the only elements that can do this. Now, what you did today was an awesome thing. Because you looked at that and you realized that's not a metal and a nonmetal. And the biggest mistake people make with this next naming system is they don't look at the binary compound first and they think it's ionic and they name it as an ionic compound. You cannot do that with a covalent compound. And that's what we're talking about today. We are talking about a covalent compound. Covalent compounds operate differently. Okay? They operate differently. All right? So let's take a look at this. This is in your notes, ladies and gentlemen. We will come back and name this. Okay? But this is in your notes, so let's get to, stupid thing. This is on slide number 46. Binary covalent compounds. Okay, remind me, what does binary mean? What? No, not together. 2. Binary means 2. Now, I will tell you right now, there are ternary covalent compounds. Covalent compounds with 3 or more elements. There are covalent compounds with hundreds of elements in them. They're called organic molecules. All organic compounds are bonded covalently, not ionically. Okay? But a binary covalent compound is 2 elements combined together. Now, what kind of elements are they? 2 nonmetals. And to be covalently bonded, instead of gaining or losing electrons, they are sharing them. They are sharing them. That is the definition of a covalent compound. 2 different nonmetals bonded together by sharing electrons. Okay? Bonded together by sharing electrons. Involves only nonmetals. There are no charges here. That is a very important thing. In a covalent or in an ionic compound, the total charge must be 0. In a covalent compound, it is already that way because no atoms are going to gain or lose electrons. They're simply going to share them. So all those charges that we talked about, -4, -3, -2, -1, doesn't mean a thing for a covalent compound. Doesn't mean a thing. They are not going to give away or gain electrons. They are simply going to share them. Okay? So there are no charges. Their formulas, therefore, do not have to be reduced. In ionic, we need to reduce it. Why? We don't want 10 ways of writing the same compound. In a covalent, you don't have to reduce them because they're sharing electrons to fill their energy level, and they will do so in a way where maybe it's an even number of these and maybe it's an even number of these that come together. So we don't reduce any covalent compounds. And for this, we use prefixes for naming the elements. Now, here's the good news, ladies and gentlemen. I already gave you the first 10 prefixes. They're on your periodic table. Okay? So, take a look. Ionic or covalent? Why? Okay, there is a metal in it. Therefore, this has to be an ionic compound. Absolutely, good job. What's another way of knowing that that one is ionic for sure? Thank you. I am only going to give you binary covalent compounds. If there are 3 capital letters in it, ladies and gentlemen, it is automatically ionic. Automatically ionic. All right. PAS, ionic or covalent? Jade, you started out good and then you kind of faded off, and I don't know what your final answer was or if you got one. Why? Phosphorus is a nonmetal, so it is covalent. By the way, where are metals always in a compound? If there are only 2 elements, where are they always? At the start. Now, there is a time where there may not be a metal in your compound, correct? In our ionic system. But if there is no metal in our ionic system, what kind of compound does it have to be? Ammonium, which means it's going to be ternary because ammonium has to be with another element, correct? So now we go back to that rule that Ariana reminded us of, which is if there are 3 elements in there, it cannot be covalent. Okay? 2 elements, first one's a nonmetal, automatically covalent. Automatically. Okay? Automatically. Jade, you look confused by that. 2 elements only. And the first one is a nonmetal, has to be covalent. Has to. There's no other option. Okay? SR3S2, ionic or covalent? Ionic or covalent? Why? Because SR is a metal. BaCl2. BaCl2. Claire. It's ionic. Barium is a metal. C2H6. C2H6. Safira. Covalent. First one is a nonmetal. Carbon is a nonmetal. Has to be a covalent compound. SF6. SF6. Jasmine. That's a covalent as well. Sulfur is a nonmetal. PBC. Ethan. PBC. Why? Because Pb is a metal. Has to be ionic. AgCl. Yasmin. Ionic. Silver is a metal. COO. My bad. COO. Jonathan. Ionic. Cobalt is a metal. CO2. Crystal. CO2. Ionic or covalent? The second one? Covalent. Covalent, absolutely. Carbon is a nonmetal. CCl4. Alan. Covalent. N2O4. N2O4. Lily. Covalent. Now, again, ladies and gentlemen, I'm trying to give you a variety of ways of doing this. What right away in N2O4 tells you it has to be covalent? You're absolutely correct, and I'm not arguing that with you. But there's another reason you can look at that and say that has to be covalent. It's not reduced. It's not reduced. Okay? So again, sometimes you're going to look at it and you may miss the fact that it's not a metal at the start or that it's not a nonmetal. If you see something that should be reduced and isn't, another sign that it's a covalent compound. Another sign that it's a covalent compound. If you see 3 elements in it, sign that it's an ionic compound. Don't even think about covalent. Okay? Don't even think about it. It's not going to happen. Questions? Okay. So these, ladies and gentlemen, are the prefixes I have already given you. And they go up to 10. I will never give you a compound where you need a prefix larger than 10 in this class. Okay? So, these are the first 10. Mono means 1, that Roman numeral I. Di means 2, II. Tri means 3, Roman numeral 3. Now again, Roman numerals are used in the ionic system, not in the covalent, but we put this all on the bottom of your table together for you. Okay? Tetra means 4. Penta means 5. Hexa means 6. Hepta means 7. Octa means 8. Nona means 9. Deca means 10. Now, this is the easiest naming system that you are ever going to get, because you are literally going to describe to someone how many atoms are there and what they are with the name. So let's go back to that one that we did at the start that we couldn't name. Oops, sorry, wrong button. BH3. How many B's are there? How do we write B? What is the name? Now, here's the one thing. I'm going to hit you with the big exception right away. When your first element, there is only one of them. Normally, to describe one, what prefix would we use? Mono. So you'd be thinking monoboron, right? One boron. The problem is there are a lot of elements, or a lot of compounds, that begin with only one nonmetal atom. Now think about if you were to list these names alphabetically, to look them up. when you got to the M section, it would be huge, right? So mono is the one prefix we will never begin a name with. We won't begin the name with it. We would use it on the second element, but not on the first. And it's the only prefix we don't use to begin. If there's 2 of something, we're going to start out di. 3 of something, we're going to start out tri. 5 of something, we're going to start out penta. The only prefix we do not begin with is mono. Only because it would put everything into one huge category. It would be very difficult to find the element, the compound that you're looking for in a resource. Okay? So with that in mind, we would begin our name with what? Boron. Now I need to describe the second element involved and how many of them there are. How many of the second element are there? And what is the second element? So, what? Okay, but it's still a compound. What? You're close. If hydrogen were in a compound at the end of it, in an ionic compound, we would call it what? Hydride. So, trihydride. 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 Boron, trihydride. 1 boron, 3 hydride hydrogens. These are still going to end in IDE. But they go back to the simple binary covalent. No ATEs, no ITEs, no losing or gaining oxygens, none of that stuff. It is simply hydride, chloride, fluoride, bromide, iodide, that ending. Now, we will put a prefix in this name for sure, at least in the middle of it. Because you will describe how many of the second element there are, even if there is only 1 of them. You will use mono for the second element, just not for the first. So you are going to always see a prefix name, tri, when you are writing a covalent compound. Okay? So if you look and suddenly you're seeing tris and dis and tetras and things like that, you are looking at covalent compounds. Now the important thing is when you take a name and write a formula, don't put those charges up there. Don't do the charges and crisscross them, and that'll never work. You're going to write exactly what the name tells you. Okay? Exactly what the name tells you. So let's take a look at a couple of examples here. Okay? Sulfur dioxide. Please remember there are no charges. Sulfur. What's the symbol for sulfur? S. How many of them? Remember, a prefix goes in front. And while the prefix goes in front, in a formula, that number goes after the letter. Right? So sulfur, how many are here? 1. Dioxide. 2 what? So what's your formula? Thank you. SO2. That's it. You're done. That's it. You're done. Okay, but I want to throw something at you real quick. SO2, right? No problems with that? We understand that completely? What's that? You're right. That is the charge of oxygen. I'm sorry, but that's not what it represents here. What? Hypo what? Hypo what?
Sulfate.
Hypo what?
Oh, sulfite.
Thank you. This is sulfate, SO4 minus 2 that has lost 2 oxygens. Now, that would have to be put with a what? To make a compound. Starts with an M, ends with an ethyl. Metal, good. A metal. So, please understand, this is a complete compound because there is no charge up there. This is a polyatomic ion that still could be part of a compound. Okay? So, understand, this can go into a compound. This is the whole thing. Okay? So we got to be careful. When you look at it, that little charge makes a big difference on how what we would do with this thing. That charge means that it is an ion ready to attach to a metal. Here, this is a covalent compound. Okay? This is a covalent compound. All right? All right. Wonderful. Excellent. Amazing. Carbon tetrachloride. Carbon tetrachloride. So, what element and how many begin our compound? 1 carbon. Okay? 1 carbon. Tetra means what? 4 what? So, formula. CCl4. CCl4. 1 carbon, 4 chlorines, writing down exactly what the name is telling you. It's telling you how many. It's telling you what elements are there. All you have to do is write it down. The only tricky thing, this is not a crisscross method, ladies and gentlemen. This is a prefix telling you how many of these there are. So we write it after the symbol in our formula. And again, you'll notice we still never write what number. We still never write once. That's an all-time rule. All-time rule. Okay? Questions? Okay. Dinitrogen pentasulfide. Dinitrogen. Jalen, what does dinitrogen mean? To what? 2 nitrogens. What does pentasulfide mean? What does pentasulfide mean, Stephanie? Okay, so when we put 2 nitrogens and 5 sulfur together, ladies and gentlemen, we get N2S5. A much easier naming system. A much easier naming system. You don't have to do those charges. You don't have to crisscross. You don't have to make sure the total is 0. Okay? But don't ever reduce these. If these can be reduced, if it's di and tetra, don't reduce them. Okay? You write exactly what the name is telling you. Questions? Trisilicon heptaphosphide. Trisilicon heptaphosphide. What? 3 silicon. What's silicon? Okay, I meant what was its symbol? SI. Good. Heptaphosphide. Heptaphosphide. Divine, what's heptaphosphide? Do you remember what hepta means? Good. 6. Actually, no, sorry. Hepta is what? 7. 7. But you'll have that on your periodic table. Okay? What's phosphide? Yep. What element? Which one would come down to being phosphide when we changed its ending to IDE? Okay. Linda, can you help her? Phosphorus, yeah.
Oh, I didn't know that's what you were asking.
Oh, okay. Trisilicon Si3. Heptaphosphide P7. Si3 P7. Questions? Okay. So let's try it the other way. What is NO2? What? Nitrogen dioxide, not mononitrogen? No. Nitrogen and oxygen. One nitrogen, two oxygens, nitrogen dioxide. That's it. That's your whole naming system. Questions? I'm giving you a minute to type it up. Here's the good news, ladies and gentlemen. On a test, I'm not going to do this. I'm not going to go, what is this? Because what is this? No.
Oh,
What is it? Nitrite. I'm not going to do that to you. Okay? Not going to do that to you. I'm not going to give you part of a compound with a charge and ask you what it is. But understand, you can have nitrogen dioxide, NO2, and you can have nitrite, which is a polyatomic that will go with another element. Okay? That will go with another element. All right? C3H8. C3H8. Anna, how would we say C3? Tricarbon. How would we say H8? How would we say H8, Maya? No, don't, ooh, be careful. I can accept some minor spelling errors, but what happens when she said hydroxide, ladies and gentlemen? Hydride is right, but what would happen if you accidentally put hydroxide? It's a what? Yeah, you accidentally named a polyatomic. That OH group that's on the back, okay? So hydride is what it would be. So tricarbon octahydride, okay? Tricarbon octahydride. Questions? Questions? XeF6. XeF6. Xenon hexafluoride. Is he right? Yes? Good. What? Hexafluoride? What was it? Xenon? Xenon. Xenon hexafluoride. Xenon. The what? The noble gas? What the heck is it doing in a compound? Well, I hate to tell you this, ladies and gentlemen, but for every rule in chemistry, there's an exception, and there's no exception to that rule. The noble gases don't combine under 99% of the time circumstances. I will never give this to you on a test. This should not exist. It does, we're not sure why, probably because of the fact that xenon's so far down on the periodic table that electrons do some really weird things. Really weird things, okay? Stuff that you're going to learn about if you take college chemistry or if you take AP chemistry or whatever. It can happen. We could name it, again, like we said before. We can name compounds that don't exist because we have a naming system that can account for it. Okay? And again, this weird, crazy exception. All right, good. Last one. B2I5. B2. Dora, B2. Bingo! Oh, wait, sorry, never mind.
Diboron pentaiodine.
Okay, do the whole thing. You're good. Go ahead. What was it again?
Diboron pentaiodine.
Diboron pentaiodine. Please remember, do not put IDE with the first nonmetal. Only the end of the name. Should have pointed that out. Didn't. Nice job. Okay, questions? All right, you've got a worksheet on covalent compounds, but I also have something else for you to do if you're challenging enough and you want to go do it. What I have here, ladies and gentlemen, is a little game called Chemical Craps. Okay? So what you can do is you can go back to the table and you can grab 2 of these dice, ladies and gentlemen. And you can roll the 2 dice. And you will get a compound. And I would like you to then just name the compound. Okay? Now, all of these are covalent compounds. Now, here's the other thing, ladies and gentlemen. I do not expect you to know which nonmetal to write first in a covalent compound. Okay? That is something that I have to set up for you. I'm not going to get into how we determine it. It has to do with the electronegativities and all kinds of weird stuff. We're not getting into that. Okay? But if you want to take 2 of these dice, the ones that are on the left-hand side of this box have to go first in your compound. The ones on the right-hand side of the box have to go second. And please try to take them as a set because you would never roll something like N3, right? That just wouldn't happen. So you could do it with these, but again, you may get some weird compounds and you may have to ignore occasionally 1 or 2. If you take them by sets, you could go play Chemical Craps back at a lab station if you want. You can work on your worksheet if you want. You can work on the other worksheets if you want. But find something to work on, ladies and gentlemen, because next week, Thursday, is your unit test. Let's do these by sets. You're welcome. No, hey, you know the house rule, right? The house rule is if any dice hits the floor, you move the house stays out.
Okay. Sure.
So if any die hits the floor, you owe the house $10 on the house. So you owe me $10.